Hello, this is Adam. We're happy to assist you with the upcoming presentation. Let us know if you need any help, and we'll be glad to be of service. Introduction to Secure Coding Practices. Secure coding practices in application security testing are foundational principles and techniques aimed at reducing vulnerabilities and enhancing the overall security of software applications. These practices involve implementing measures to prevent common security threats such as injection attacks, cross-site scripting, and unauthorized access. By adhering to secure coding practices, developers can validate and sanitize input data, encode output to prevent malicious injections, implement robust authentication and authorization mechanisms, configure systems securely, and ensure effective error handling and logging. These practices not only mitigate the risk of security breaches but also contribute to the reliability and trustworthiness of the software. Understanding security threats is essential for developing effective strategies to protect software applications from malicious attacks. Security threats refer to potential risks and vulnerabilities that can compromise the confidentiality, integrity, and availability of data and systems. Here are some common types of security threats. #injection attacks. Attackers inject malicious code into input fields of an application, such as SQL injection or code injection, to manipulate or extract sensitive data from the system. #cross-site scripting, XSS. XSS attacks involve injecting malicious scripts into web pages viewed by other users. These scripts can steal session cookies, redirect users to malicious sites, or deface websites. #cross-site request forgery, CSRF. CSRF attacks trick authenticated users into executing unwanted actions on a web application without their knowledge. Attackers exploit the trust relationship between a user's browser and a website to perform unauthorized actions, such as changing account settings or making transactions. #man-in-the-middle, MITM, attacks. An attacker intercepts communication between two parties, such as between a user and a server, to eavesdrop, modify, or inject malicious content into the communication flow. This can lead to data theft, session hijacking, or unauthorized access to sensitive information. #denial of service, DOS, and distributed denial of service, DDoS, attacks. Aim to disrupt the normal functioning of a system or network by overwhelming it with a large volume of traffic or requests. This can lead to service degradation or complete unavailability, impacting the user experience and causing financial losses. Principles of secure coding serve as fundamental guidelines for developers to build software applications that are resilient to security threats and vulnerabilities. Here are the key principles. #input validation. Validate and sanitize all user input to ensure that it meets expected criteria and does not contain malicious code or unexpected data. Proper input validation helps prevent injection attacks, such as SQL injection and cross-site scripting, XSS, by rejecting or sanitizing potentially harmful input. #output encoding. Encode all output data to prevent unintended execution of scripts or injection of malicious content into web pages. Output encoding converts special characters into their respective HTML, URL, or JavaScript representations, thereby mitigating the risk of XSS attacks and other injection vulnerabilities. #authentication and authorization. Implement robust authentication mechanisms to verify the identity of users and ensure that only authorized individuals can access sensitive resources or perform specific actions within the application. Use strong authentication methods, such as multi-factor authentication, MFA, and enforce proper authorization controls, such as role-based access control, RBASI, to limit privileges based on user roles and permissions. #secure configuration. Configure software components, servers, and environments securely to minimize the attack surface and reduce the risk of exploitation. #error handling and logging. Implement effective error handling mechanisms to gracefully handle unexpected errors and failures, providing informative error messages to users without revealing sensitive information that could be exploited by attackers. Tools for secure coding practices. Various tools are available to assist developers in implementing secure coding practices and enhancing the security of software applications. These tools automate the detection of vulnerabilities, analyze code for security flaws, and provide guidance on remediation. Here are some common tools for secure coding practices. #Static code analysis. Analyze source code or binary code without executing it, identifying potential security vulnerabilities, coding errors, and compliance issues. #Dynamic application security testing, DAST. Assess the security of running applications by sending various HTTP requests and analyzing responses for vulnerabilities. They simulate real-world attacks and help identify security weaknesses from an external perspective. #Interactive application security testing, IAST. Combine aspects of SCA and DAST by analyzing application behavior during runtime. They provide real-time feedback on security vulnerabilities and their impact on the running application. Thank you for watching our presentation. We hope it was valuable and informative. For questions, contact us at info@espincorp.com or visit our website. Thank you again and have a great day.